La 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 날 좋아한다고
Good day everyone! Today we are going to discuss arcs, chords, and angles found in a circle. So before we begin our discussion, please like, share, and subscribe to my YouTube channel for more information about mathematics. So now, we will identify first the arcs and angles found in the circle. So what is an arc? An arc is a part of a circle. In other definitions, an arc is part of a circumference of a circle. Arcs can be formed using the endpoints of a line segment. So in this case, in our figure on the screen, we can tell that an example of arc is arc BC, since it is part of the circumference of the circle, which is circle O. So, if for example, we have an angle COB, then we can have arc CB as the given arc of the particular angle. Next is a semicircle. A semicircle, or half of the circle, is the union of the endpoints of a diameter and all points of the circle that lie on one side of the diameter. Its measure is exactly 180 degrees. In the following figure on the screen, we can tell that arc EHG is an example of a semicircle, and arc EJG is also an example of a semicircle. In this case, we have the diameter EG, and all the points on the circle that lie on one side of the diameter, for example EG, is considered as a semicircle. So the union of endpoints of the diameter EG, which is from E to H, then H to G, is called the semicircle. Its measure is exactly 180 degrees. Since the measurement of a circle is 360 degrees, therefore, the measurement of a semicircle, which is exactly half of the circle, is 360 divided by 2, which is equal to 180 degrees. A central angle is an angle whose vertex is at the origin. Remember that the angle is formed when two non-collinear rays meet at a single point named the vertex. In this context, the vertex is at the center of the circle itself, and the rays of the angle are the radii of the circle. So we have here an example of a central angle. We have angle BAC, which is a central angle, since the vertex can be found at the center of the circle, in this case point A, and the rays of the angle are the two radii of the circle, which is line segment AB and line segment AC. The arc BC can be considered already an arc. The next is the minor arc. A minor arc is an arc smaller than a semicircle. A central angle, which is subtended by a minor arc, has a measure less than 180 degrees. So in our example, we have the arc BC as a minor arc, since it has a central angle whose measure is less than 180 degrees, and that central angle has a subtended arc BC, which is less than 180 degrees also. Therefore, it is a minor arc. Minor arcs can be represented by only 2 points within the arc. So in this case, minor arc in the figure is minor arc BC. Next is the major arc. A major arc is an arc greater than a semicircle, and the central angle, which is subtended by a major arc, has a measure more than 180 degrees. We have here an example on the screen. If arc BC is the minor arc, then the rest or the remaining arc found in the circle are called the major arc of the circle. So in this case, we have arc BDC or arc CDB as the major arc of circle A. So, we can conclude also that arc BDC plus arc BC is equal to 360 degrees, with arc BDC greater than arc BC. And remember that when we are naming major arcs, we are naming 3 points. So in this case, we have major arc BDC or major arc CDB. Congruent arcs. In a circle or congruent circles, congruent arcs are arcs with equal measurements. We have here an example of congruent arcs. We have arc AB and arc CD. Since arc AB is equal to 45 degrees and arc CD is also equal to 45 degrees, we can conclude that arc AB is congruent to arc CD. An inscribed angle is an angle whose vertex lies on the circle and whose sides contain chords of the circle. So the difference between the central angle and the inscribed angles is that the central angle has a vertex on the center of the circle itself, while the inscribed angles, the vertex lies on a point in the circle. And the rays of the inscribed angles are chords of the circle, not unlike the central angle, whose rays are the radii of the circle. So we have here angle ABC as an inscribed angle of circle O in the figure shown on the screen. So we can conclude that chord AB and chord BC are the sides of angle ABC, and then B is the vertex of the angle which is found on the circle, not on the center but on the circle. Therefore, we can tell that angle ABC is an inscribed angle. So that ends our discussion. So I hope that you've learned something on this video, and remember to like, share, and